Hello everyone. Today we are going to be learning about moment of inertia. First, before moment of inertia, we will learn about some types of motion. There are different types of motion like linear motion, circular motion, rotational motion, oscillatory motion, periodic motion. But here we are talking about two. Those are linear motion or translational motion and rotational motion. Okay, so in translational motion, or linear motion, suppose a body is moving, yeah, in linear motion. Suppose this is the center of mass, where all the mass of the body is supposed to be concentrated. Then the body moves in a certain path. Then the property exhibited by this body is inertia. So next there is rotational motion. Okay, so in rotational motion, the property exhibited by the body is moment of inertia. So first let's give you an example. Okay, this is an axis, y-axis, and this is a body, a rigid body, which has a fixed shape and which doesn't undergo any change in configuration on application of external force. Let's say this is a mass, yeah, and this is the radius. So from moment of inertia, we can tell that moment of inertia is equals to mass times square of radius for a single particle, for a single mass. So its unit is gonna be kg meter square. Okay. Okay. So now we can see that the moment of inertia depends upon two things. One is the mass, and the another is the perpendicular distance. Square of perpendicular distance from the formula. Okay, let's define moment of inertia. Mathematically, moment of inertia I equals to mr square. So it is defined as the product of mass and square of perpendicular distance from the axis of rotation. So this is the axis of rotation. Yeah, it's rotating. And this is a body. Okay, here is a body of mass m and radius r. So from this we can see that if the axis of rotation is changed, the definition says it from the axis of rotation. So if the axis of rotation, this thing over here, is changed and placed around somewhere here, then the radius also changes, but the mass is still over here, and new radius is smaller. So on shifting the axis of rotation, there is change in moment of inertia. Let's calculate the moment of inertia of a rigid body. Suppose this is a axis this is a rigid body, okay, and there are some points, okay. So let's say this is m1, m2, m3, m4, and 2m1, mn, and these are the different radius associated with the mass of different particles of the body. So this is r1, r2, r3, r4, and then rn radius. The body is rotating about a fixed axis. Let's consider a rigid body consisting and a number of particles having masses m1, m2 to mn. The body is rotating about an axis y prime. As the body is rotating, all the particles are also rotating. Let r1, r2 to rn be the perpendicular distance from the axis of rotation for the particle m1, m2 to mn respectively. Then for particle m1, moment of inertia I1 is going to be equal to m1 r1 square. For particle m2, I2 is going to be equal to m2 r2 square. Likewise, for particle mn, in is going to be equal to mn rn squared. Okay. Now, total moment of inertia I is equals to I1 plus I2 plus 2 in, which is I1 is equal to m1 r1 square plus m2 r2 square plus mn rn squared. So for this we can write this as summation I equals to 1 to n miri squared. So this is how we calculate the moment of inertia of a rigid body. In the next video, we will talk about radius of gyration.